Okay, in the previous lecture, we have discussed important concepts in any programming language and in R specifically variables. So the point of the discussion was that we can declare variable that can hold single values such as x equals 5, or alternatively we can assign x the value hello world, which is not a number obviously, but rather a string or text. And also we can assign the variable value of true or false. That's a special type of variable which is called Boolean or logical. So if we assign variable single value such as 3.5 or the single phrase hello world or single false or true, that is something that's called scalar. Also we discussed that an extension of the scalar is something that's called vector. So vector is you have a vector variable when you have a single variable such as x, and that variable points to not a single value but to a collection of values. For example, in this case, x points to the collection 2, 4, and 6. And the way how we access the individual, let's actually switch to R. Okay, so the way how we access individual values of the vector is we have to provide an index. So in this case, for example, I have variable a, which is a vector consisting of 3 numerical values, 2, 4, and 6, and they're enumerated. 2 is in the position in the first position, 4 is in the second position, and 6 is in the third position. So if I'm running the command a3, that gives me the third element, and you can see right here at the bottom that gives me number 6, which is third element of my vector. Okay, so we discussed scalar variables, which take single value, vector variables, and now we're going to switch the gear a little bit and discuss actually what's going to be relevant for the rest of the semester. We're going to discuss a two-dimensional variable type which is called data frame. Okay, so you can think of vectors such as this, for example, vector which consists of 3 numerical values, as a one-dimensional variable. So why do I tend to think about vectors as one-dimensional variables? This is the first element, second, third. So it's like you have ordered set of elements. So visually you can kind of imagine that as if you would have a bunch of different elements, and they are just aligned along the horizontal axis. So you have first x, second x, third x, etc., etc. Now let's take a look at the two-dimensional case. Now for that we're going to actually have to discuss a special way, a very popular way, how the data are being stored in real life situations. So that's how a lot of times data sets, data values are really being used for the analysis purpose. So let's discuss something that's called CSV files. All right, I'm going to switch back to the I'm gonna switch back to the lectures. Actually, I don't have it in lectures. Okay, so let's discuss a special way, a special format to store the data, which is called CSV. All right, so go ahead and get and start on your machine. Very simple editor, text editor. It can be Microsoft Word, or I chose to start a Notepad. So this is very basic text editor, right? And what I'm going to do is this. I'm going to create a file with the data inside. So let's say, for example, I have 2 students in the class, and I have grades for them. Okay, so first column, and I'm going to organize the information in columns as we normally do, right? So first column I'm going to call column with names, and then second column I'm gonna have grades recorded in there. Okay, so that's going to be my first line. You can see that I just type the text name and then put a comma and another text grades, and now I'm going to so these are going to be names of my columns. Okay, so now I'm going to actually populate my file with data. So by the way, important part is do not leave any spaces. Okay, so because spaces will become part of your so for example, if I'm going to put space here, then my column is going to be named not grades but space grades. Okay, so keep it clean, no spaces. All right, so now I'm going to hit enter, and first name in the class is going to be John, comma, again no spaces, and let's say John gets a grade of 87. I'll go ahead and hit enter one more time, start a new line. Jane, my second student, and she is going to have a grade of 93. Okay, so that's going to be my third line. And go ahead and hit enter, but don't type anything. This will tell the program that after 93, because we have a new line after the number 93, that means that Jane, comma 93 is your last line in the file really, and the next line is going to be empty. So this will indicate for the program that this is the end of file, effectively. So this is the format which is called CSV, comma separated values. You can see why it's comma separated values, right? So I have value name, comma, and the next value grade. So comma basically is not part of any of the values recorded in the file. Okay, this is just a way for me to separate values from one another. So it serves as a separator, as a delimiter. So and that's why these file types are called CSV, comma separated value files. So I'm going to save that, save as, and let's actually do this. On your machine, if you are running a PC, okay, go ahead and on the disk C, create a folder called data. I already created that, and it's empty for me. Okay, so on your machine, in the disk C, create. So click on the new folder, and here type the data. Right. So I'm not going to do that because I already have that. But how do I delete that? Okay, delete. Alright, so go ahead and create the folder data. That's where we're going to store all of our files, okay, that we're going to use in this class. So I'm going to save that file, which I just created. Very simple file, right? It has two columns. Column which is called names, and column which is called grades, and a couple of values in each column. I'm going to save that in the folder data. Now, I don't want to save it as txt, so here you have to pick all files, and I'm going to call it my first CSV file, and I'm going as you can see, I'm leaving no spaces in the name, right? I'm using underscores. My first CSV, again CSV stands for comma separated values file, okay, and I'm going to say dot and give it an extension CSV. So I'm gonna hit save. And now let's take a look what happened. Okay, so I'm going to open the my computer right here, and if I go to my disk C, folder data, whoops, that one shouldn't be there. I'm going to erase that. Okay, so you can see that here's my file which I just created, and the type of the file is Microsoft Excel, comma separated value files. Well, I didn't create an Excel file, right? All I did was I saved the CSV, the file, the data in the CSV format. By default, my computer assigned Microsoft Excel to handle the CSV file, and it's not unusual actually, for at least for PCs, for Windows computers. So oftentimes when you have Excel installed on your machine, this is going to be a default program to open your file. So my file, you can see it from the icon, right? Icon has Excel image on it. So that means that my computer, my operating system, associated with my file Excel as a default program to open it. So when I double click that file, double click that icon, it opens up in Excel. So I'm going to bring it over, Yeah, so this is what the file looks like in Excel. So you can see that there are no commas anymore, right? So in my file I had name, comma, grades, then John, comma, 87, Jane, comma, 93. But there are no commas right now, and what Excel did is it treats the commas as separators from different values, and it places the values in different cells in the spreadsheet. Okay, so this is how my CSV file looks like in Excel. Okay, and this format, so I'm going to close all that stuff. So this format, CSV file, is very popular in data analysis. So during this semester, we're going to analyze our data, which will be always saved in the CSV format. So you have to memorize what CSV is. Again, it stands for comma separated value format. And in the industry, in the data analytics, this is probably hands down the most popular way to store the data. Okay. All right. So now let me go ahead and try to actually show you over here an example of the two-dimensional data set. So the reason why I'm bringing this up is that you can see from did I close it? Yeah, I just closed it. From our CSV file, it looks like a two-dimensional table, right? So if I open it with Excel, the data is distributed in columns called names and grades, and each record about every individual student is a row in my two-dimensional table. So I have columns and rows. Okay, so that's why it's very important for us to discuss two-dimensional data sets. Okay, so two-dimensional data sets in R and in Python as well, by the way. That's another popular language to do data analysis. Two-dimensional data sets, they're called data frames. Okay, so I can actually create data frames myself. So let me show you. So here I'm going to leave a comment. I'm going to say create a data frame variable with students' names and grades. Okay. All right. So how do I call this variable? Well, let's call it students. Okay, students data. All right, students data, and I'm gonna put this sign. As you know, this is an assignment operator, right? I can either do that, arrow pointing towards the variable, or I can just simply say equal. Doesn't matter. So here I'm gonna say data dot frame. So I'm going to do exactly the same thing again, but this time around I'm not going to do it in the file in Notepad, just like what I did right now. But instead of that, I'm going to create by writing a command and running that command in RStudio. Okay, so the first column is going to be the point that I was actually going to make here. Let me kind of take a step back. All right, so I'm gonna open up my file again. So you can see from this file that it looks like actually two vectors, right? The first vector right here in my column, okay, the vector is called names, or name, right? And the values in this vector were John and Jane. The second column, I can also think of that as a vector. It's a one-dimensional data, right? And the name of this vector is grades. And the values are 87 and 93. So I can think about two-dimensional data set, this one right here, okay, as a collection of two vectors, vector with names and vector with grades. And that's exactly what I'm going to do. Actually, let me bring back the RStudio. Yeah, that's exactly what I'm going to do in my command right here. Okay, so I'm going to say that my first column, let's kind of create it identical, right? I believe I called it name, right? Not names, but name. Name equals, and that's a vector. And you remember that we create vectors by running the function C. C stands for combine, right? So it's a combination of two things. Both names, John and Jane, are not numbers. They're characters, right? Well, not characters, but text. Text type of the data. So therefore, I have to include them in the quotation marks. So John, comma Jane. All right. So this is my first vector. Okay, first column called name, John, Jane. All right. The second one was, I believe, grades, right? So grades, and just the same, going to be vector, so I have to use the function c, and the values were 87 if I remember correctly and 93. Okay, so these are numbers, and I'm not going to include them in the quotation marks. So let's go ahead and run this line, and if everything runs fine, you should see at the bottom only blue color. So if you see the red color, probably every once in a while we're going to get that. Color red means, uh-oh, you made a boo-boo. Okay, so something went wrong. There was a mistake. You either misspelled something or forgot, commas or something else. So, and this is our two-dimensional data set. So let's take a look at that. Students data. And here at the bottom you can see that it looks pretty much, I'm going to bring up, hold on, I'm going to bring up my data set back. You can see that it looks pretty much identical to what I have in an Excel file. This is my CSV file and this is my data frame, right? So data frame looks pretty much exactly the same as my CSV file. I have column name, John Jane, and I have column grades, 87, 93, okay? So it's similar organization. That's why from now on, everything that we're going to do, how we're going to read the data in, so the data is going to be stored on the disk on your computer physically in form of the comma separated value file, CSV file. But we can't work with data sitting in the file somewhere on the disk. We have to bring the data in the active computer memory. So therefore, ladies and gentlemen, let me introduce you to the next topic of our discussion, and that would be how do we read the data in from the file. Okay, so let's turn our attention to let's see, where is that? Yeah, right there. Okay, so go to Scalar, to our course, Applied Business Statistics, and all the data sets that we're going to be using I will post in the link in the folder here, data sets. So go ahead and click on the data sets, and over there you will see the very first data set, titanic.csv. It's comma separated value file. That's actually the file that I'm using as my first example in data introduction to data analytics course, which is a core course in the Lutheran School of Business. But just to show you how you can read the data from the file, I use the same example. So go ahead and click on the file, and it will download onto your machine. Oh, one more important thing that I have to emphasize. Okay, do not ever use Microsoft Internet Explorer. I'm being serious right now. As funny as I might sound, this is actually serious. Okay, Internet Explorer is pretty much dead browser. Okay, it has a lot of issues, including security issues. So I'm using, and another thing why I'm bringing this up is, in the past I had issues with students downloading the files and they're not downloading correctly, or they can't find them, or they can't open it. So something happens. I have no idea why that happens, but if you by any chance using the Internet Explorer, stop that immediately. Okay, use Chrome, Google Chrome, which is the default browser that I'm using, or if for some reason you don't like Chrome, then use Mozilla Firefox. That's definitely, either one of them is better than Microsoft Internet Explorer. Okay, so therefore all these actions, downloading the files and whatnot, they have to be done in Chrome or Firefox. Okay, so over here at the bottom, I believe I have the file, and go ahead and click show in the folder, and that will bring up the my computer, right? Folder downloads. Okay, so oh god, where is that? Titanic, right there. Okay, Titanic example. Apparently I downloaded that already, twice actually. So here is the Titanic and my downloads. So since we discussed before, everything that we're going to do will be sitting in the folder on the disk C in the folder data. So when you download the file, just go ahead and move that file to the folder data. How to do that? Here's what I do. I right click, cut the file, so it basically eliminates the file from here but keeps it in the memory. Then I go to disk C, drive C, to the data, and paste. Bam, there it is. Okay, so this is my file Titanic, and you can see it's also a CSV file, right? Comma separated file. Let's actually take a look at the file. So I'm going to bring it up, and because CSV file by default is opened with Excel. There it is, CSV file in Excel. You can see that I have 3 columns of data, right? So first column is class. So these are basically passengers of Titanic, you know, the ship that had unfortunate encounter with iceberg and sank. So let's take a look at how many data values there are. Oh God, let me move it over here a little bit. There are 2201, because the first line is column names, right? 2201 records in this file, logically about every passenger of the Titanic. Okay, so this is a fairly simple file. You can see that first column contains data about each of the passengers, right? Which class they traveled on Titanic, and let's take a look at what are the options, right? So on Titanic, they could be a part of the crew, first class, second class, or third class. All right. And what else do we know about each passenger? Age. Okay. Age. There are 2 options: adult or a child. Normally, age is a numerical variable, right? So somebody is 12 years old, somebody is 37 years old, 25, what have you, right? So that's a number. Here we actually store the information differently. You can see that every passenger was classified as adult or a child. So how did we do that, or whoever created that file? Well, apparently they adopt some sort of the cut-off age, right? So, for example, let's say 18. So if you're under 18, you're classified as a child. If you're above 18 or older, then you're adult. Then the third column is sex, male, female. No surprises there. And the last column is, you know, that some passengers survived, some passengers died, right? So these were 2 outcomes out of this trip, right? So survived, the last column, the answer is yes or no. Okay, so you can see that we don't have any numerical variables, right? In fact, all of them are nominal, right? They're categorical. Oh, we actually didn't discuss that yet, so let's leave this discussion. Let's leave this discussion until later. Okay. So that's my file, and I'm going to close the file. And how do I bring that file into my into the memory? Well, here's how we do that. So my point, what I'm trying to make here is, here when I created a data frame by running this line, this command, we're never going to create data this way. We're always going to read the data into the data frame variable, but the data will always sit inside the file, just like what we did, right? We downloaded the file, and the file right now is sitting on the hard drive of my computer. Okay, so I'm gonna put a comment here: read data from a CSV file, comma separated family file. All right, so here's how you do it. Since my data is about Titanic, right? So I'm going to call it Titanic data. All right. So in this variable called Titanic underscore data, and one more comment that that I wanted to make is I use underscores because, you know, I cannot do something like this, Titanic data. For any computer program, and RStudio included, that will look like 2 commands, 2 separate commands, and it will not recognize either one of them. Okay, so therefore your name has to be continuous. Okay, there are no gaps with no spaces in between. Of course you can do that, right? You can say Titanic data, one word, but it's kind of hard to read, right? So therefore I do underscores, and that's pretty standard. Some people do that. Instead of underscores, capitalize each first letter of the word. For example, capital T, Titanic data. That's probably also good. I believe it's called camel notations. It looks like camelback, right? Up and down, up and down. But that's what I am using traditionally. Titanic underscore data. Okay, so I know that the data is sitting in the file in my drive C folder data, and the file name is titanic.csv. I have to be exact here. Okay, so the command that the function that I'm going to use is read.csv, and that's actually something useful. Let me kind of take a minute here to talk about this feature. this is kind of a dynamic help, right? So as I start typing the command, if RStudio recognizes what I just typed, it gives me a bunch of options. Okay, so these are all the things that RStudio knows that start with the word read. Okay, so sometimes it's called dynamic help, sometimes it's called IntelliSense. So you start typing, and if the program recognizes what you're typing, it will give you the options, right? How your phrase can be concluded. All right, so I'm going to use the first one, read.csv. So as you can probably guess, this function opens up the comma-separated value file and reads that into the variable. In our case, it's called Titanic_data. But the only thing that I have to provide for this function is the exact location of the file. And when I say exact, I have to be precise. Okay, so let me show you. So here I'm going to say file equal. This is optional, by the way. I'm going to show you in just a minute that you don't have to do it every time. So file is located, and because I have to specify the path to the file, okay, that has to be included in the quotation marks. So because I'm running on the PC, on Mac, by the way, it's a little bit different. So for those of you who run Macs, I don't have a Mac, unfortunately, so I can show you how it's done. I'm going to actually tell you after we read the data. I'm going to tell you how to do that on the Mac. Okay, so but on PCs you have to say C, that's your drive, right, where everything is located. Then column / data is the folder where we decided to keep all of our files, right? And here I have to specify the file name, and the file name is called Titanic. It doesn't really matter if you use uppercase or lowercase letters in this case, right? And I can't leave it like that. So actually, let me show you what some of my students do. Okay, I'm gonna do stupid mistakes. Here I'm gonna say read the file Titanic. Bam. Okay, and here at the bottom you can see that it says, yeah, okay, I don't understand what you mean. There is no such file or directory. Okay, as we discussed before, blue means you ran the command successfully. Every time when you see red color, that means that something went wrong. Okay, in this case it says error. Error means that it's a no-go. Okay, so okay, I'm gonna say Titanic.csv. How about now? Do you understand that better? I run this command. It says no, I cannot understand what you mean by Titanic CSV, no such file or directory. So with computers, you have to be precise. You have to exactly specify where the file is physically located. So it's on the disk C, folder data, and then inside the folder, it's called Titanic. Let me show you another mistake that my students oftentimes do. How about this one? Folders, drive C, folder data, file Titanic. If I run that, it says again, I don't understand what you mean. There is no such thing, such file or directory. So it has to include the file specification, this three character, 3-letter extension of the file, right? That comes with the file. And when I do that, you can see that I don't have any red color, right? So this line was executed, and over here on the right side in my environment variables, you can see that I have Titanic data, 20 to 101 observations, 4 variables. That means 4 columns. Okay. So a useful feature actually is to do the following. I do that oftentimes when I teach students in my Introduction to Data Analytics course, and let's get into the habit of doing the same thing here in this class. Okay, so new function that we're going to use. Okay, it's a good idea pretty much to take a look at your data, at the structure of your data. Okay, so explore data structure. What do I mean by structure? Well, you will see in just one second. Okay, so that is done by the function str. As you can guess, it stands for structure. And again, you can see that as I start typing, RStudio shows me a bunch of choices that all start with str, but I need the first one. Okay, structure of my data, which is Titanic data variable. And again, this is a data frame, right? Because it has columns and it has records. So it's a 2-dimensional structure, X and Y, if you want. Okay. So I go ahead and run this line, and here at the bottom you can see, let me actually give it a couple of enters, you can see that my data structure looks like that. Variable name is data frame. It has 2201 observations, that means 2201 records. 4 variables, that means 4 columns, right? So the first column is called class, and the possible values are, there are 4 of them, and at least just first 2. Crew, first, that means first class, and then if you remember there was also second class and third class, right? Alright, then age was not a number, we discussed that, adult and child, right? Sex is female or male, and survived, yes or no. Now, one thing that I wanted to point out to you is the way how R and RStudio lists different values, such as, for example, possible values for the variable class. It's alphabetical order, so it reads them all, it organizes them in alphabetical order, and that's how it presents them to you. So you can see crew goes first because C goes first, F first class, that's the next one, then S second class, and T third class. That's how it's organized, right? Same thing here. Adult, child, A goes first, F, M, male, female. F goes first, no, yes, N goes first, and Y goes after that. That's why it's organized alphabetical. Okay, so and that's how we read CSV files into the computer memory. So now we can actually do a lot of different things with the with my data frame. Okay, but I promised to show you how the data, how you can read the data if you have a Mac computer, right? Now, obviously, I'm not going to be able to do it on this machine because it's a PC, but on Mac machine, when you download your file, if I understand it correctly, I had few students in the past who had, well, more than a few students actually, who had Macintosh machines, and every time when you download the data, it goes into your folder which is downloads, I believe. So if you move it somewhere, like here, I created the folder data, right? Then I believe here's what you do. Okay, you still you say tilde, and you go /. Okay, so if on your machine you move all of your data files in the folder which you create, which is called data, that's how you are going to read the file on Macintosh. But if you leave it in the downloads folder, I believe, download or downloads, I don't know how it's spelled exactly, that's how you're going to have to read your data on Mac from the downloads folder. So when you hit the download button, it goes straight into your default folder with downloaded files. Okay. So, but I'm going to switch that back to what I had before. Let's see, data. Okay. Now let's go back to this one. Okay, to students' data. So this is what our students' data looks like, right? I have 2 columns, name and grades, and I have 2 records. First column doesn't. First row, first record doesn't really count. Okay, because it's not really my data. It's how my columns are called. These are the names of my variables. First variable, first vector is called name. Second variable, second vector is called grade. So that's not that doesn't count, right? That's why in the CSV files, first line is usually not part of data. It's the names of your columns. Okay. So therefore, the data that actually is part of my data file is right here. Okay, it's John 87 and Jane 93. How do I access individual elements? Let me do it right here. Okay, how do I access individual elements of my data frame? Well, you remember how we did it right here, right? I told you that vectors are kind of like a one-dimensional structures, right? So I have first element, second, third, etc. Here, actually, I have 2-dimensional structures, so therefore, to get access to an individual element, I'll have to specify both row and the column, and the row index goes first. So, for example, John, right here, is located in row number 1 and in column number 1, right? First row and the first column, name. Okay, so therefore, If I want to get the element which is in the first column, first row, first column, here's what I have to do. I have to say student underscore data, then open, close these square brackets, just like what we did with vectors, right? But now instead of just one index, I have to specify two indices. So first row, again, row goes first. Row number 1, comma, column number 1. And if I do that, and you can see that, student data not found. Student, do you see what I did? The error is, I call it student data, but the actual variable name is students data. So every time when you have an error, don't just rush off, okay, oh my god, everything is lost. Read what the error description is telling you, okay? So in this case it says students data not found. That means more than often, or often than not, that I misspelled something. And this is a programming environment, okay? It's very unforgiving, so therefore you have to be exact. Students data, row 1, column 1, bam. It says your element is John. What if I wanted to access this one, 87, the grade for John, right? It's still in the first row, but it's in the second column, right? So therefore here I'm gonna have to say 2, row 1, column 2, and bam, you can see that this is 87. So Jane obviously is located in column, in row 2, right? So therefore if I want this grade 93, that would be row 2, but still column 2, right? And I have 93, okay? So very similar, right, to what I did with vectors. With vectors, I specify the position of the vector, so it's only one index, which position inside the vector, first position, second, third, etc. Here, because I have a two-dimensional data, I have to specify both x and y, okay? Now let me show you a couple of other things. In R, if I want, for example, all values from the record number 1, here's what I do. I'm gonna say students data, right? This time around I'm not gonna misspell it. Students data. So how do I get the entire first record? So my first record is John 87, right? So again, I'm gonna have to say, I'm gonna have to type the square brackets. I'm gonna say row number 1, comma, but instead of saying column, because I want both column 1 and 2, right? I'm gonna leave it blank. So this is how you access the entire first record. You say record number 1, but no specification for the column. And that by default means that you want the entire record number 1. Let's see what happens when I run it. Here, okay? It gives me John 87. Name John, grades 87. Okay? So if I'm going to run 2 comma nothing, that's going to give me Jane 93, right? And very similarly, I access in the same way the column information. For example, if I want the grades only, right, but no names, here's what I'm going to do. I'm going to leave the record row index blank, meaning that all rows, right, and my grades are located in the column number 2. So if I have nothing, comma 2, that means all rows for the column number 2. And if I run it, there you go. You have 87 and 93. So the entire column number 2 is displayed for me. Okay. All right. So in the time remaining, we have about 10 or so minutes, right? Let's discuss how do we access the individual columns programmatically. Okay. For example, what if I want to calculate counts, okay, of all passengers who traveled as part of the crew, first class, second class, or third class, okay? So here's what I do. I'm going to have to create a table, okay, out of the value. So the table literally will contain counts, right? How many passengers in the crew, first class, etc. So counts of, let's call them classes, right? Classes. Table of counts, right? Table of counts of classes. All right. So here is how I do that. I'm gonna need a new variable. Let me call class. This variable I'm going to call class underscore counts. Okay, and in the class counts, I'm gonna say new function again, you guys. Okay, table. So create a table for me, and you will see exactly what this one does. Okay, but here is my data set, right? It has 4 columns. It has a column called class, that's a variable, and column age, another variable, sex, and survived, etc. And I want just the counts of classes, right? How many people traveled as part of the crew? How many people traveled as part of the first class, etc. Okay, so if I'm going to say Titanic data, that's going to probably give me the entire. Let's actually run that. Let's see if it does anything. Yeah, it does something. So let's see. Class counts. Class counts. Okay, if I want to run the class counts, there you go. Okay, it actually gives me the entire summary. Tells me. That's actually a little weird, right? Class crew, adult child 30. So it gives me actually it looks like it gives me a 2-dimensional. Yeah. So I don't know how to interpret that. So since I want to concentrate on one specific column in my entire data set, and that would be the first column, which is class, I need to tell the function table that you have to look only in the column called class. Here is how we're going to do it. Again, we're going to do a lot of this operation as we go through this semester. So that step is kind of important. First, I have to type the variable name, my data set, right? It's called Titanic data. Then after that, immediately with no spaces, okay, important, don't leave any spaces, just like we did in the variable names, right? There is no students space data. Okay, we go with underscores. Okay, so here after the name of my data set, I'm gonna have to type $, and look what happened. Immediately after I type $, after my data set name, R actually knows that there are 4 columns, right? 4 variables: class, age, sex, and survived. So I'm going to go with class, and when I run this line, well, it created probably counts for me. So let's check it out. Okay, so I'm gonna say please show it to me. So because all of these results are recorded in the variable class underscore counts, I'm gonna just run this line. Okay, and remember again, we discussed that in the previous lecture. You can either hit the run button, so you can either highlight your entire command and hit the run button, or click somewhere so that this line is active, or click at the end, in the middle, doesn't matter. Or I can just simply hit Control Enter, and it will run the same line. Alright, so here's the deal. Out of how many? I forgot how many people did we have in this file. Out of 2,201 person in this data set, part of the crew were 885 people. So I'm guessing, roughly speaking, 35% or something like that. Guesstimate. Right, first class 325 passengers, second class 285, and third class 706. So third class was the most populous one in terms of passengers, right? Which makes sense. It's probably the cheapest class, right? Okay, so this is my this is how I create a tabular summary of one single variable. Okay, so again, I'm using the function table. Okay, but I have to pass the exact precise variable, right, to my function. So I can't just say, hey, tabulate anything that you will find in my data. Okay, I'm tabulating one exact specific column, right? One exact specific variable, and that would be column called class. So that's how we're going to standardly access a column of data in our data sets. First, you type dataset name, Titanic data, then you put $, and after that, you have to have the name of your column, and there should be no spaces. That's important. Okay, if I do that, let me show you, then well, apparently it's going to work, right? Huh. That's amazing to me, actually. But good practice is don't leave any spaces. Okay, don't leave spaces in the variable names, and don't leave spaces between the dollar signs and the data set name and the variable name, the column name. Okay, so next thing that what I can do, and it's probably going to be the last one for this part, is okay. So I know that I had most people traveling as a crew. Then the second most populous was third class, etc., etc. But what about percentages? Okay, these numbers by themselves, okay, they're good, but can I look at percentages? What percentage of all people on Titanic were crew? Third class, first class, second class, etc. I can certainly do that. So let me show it to you. And again, I'm going to leave a comment. So type the pound sign. That's how we start comments, right? Calculate percentages of each class, right? Crew, first class, second class, etc. All right, so that is done by using another function which is called prop dot table. Prop, as you can guess, stands for proportion, right? So, and that's the reason why, by the way, I have saved all of my counts as a vector. So this is essentially a vector, right? Crew 88, first class is 325, etc., etc. So I have 1, 2, 3, 4 different values. Okay, so I have to pass that vector variable class count to my function prop table. So class count, okay, and that function will calculate proportions. And as you can guess, the proportions should add up to 1.0, right? So percentages in different classes add up to 100, everybody on Titanic, right? So if I run this line, there it is, okay? So crew was, well, I guess 35, it actually was 40%, 40.2% of the entire ship, right? First class was 14.roughly 8%, second class 12.9, well, close to 13%, and the third class was roughly 1/3, right? 32%, okay? So that's how we create the tabular summary. So you can get either counts, just by using the table function, or you can get proportions by taking the results of the tabulation, right? So you tabulate your column, record it in some variable, and then you call the function prop table, table of proportions, and pass this vector of the values, and it gives you the percentages. Okay, so that's how we create summary. Essentially, so we summarized, if you think about it, what we accomplished here is we took the 2201 observation, right, for 2201 passengers, and we created a 4-number summary. Okay, so we took a bunch of data and created just a handful of numbers that characterize the entire population of the Titanic passengers, and that's what statistics is all about, really. Okay, it's taking big volumes of data and trying to summarize them with just a few measures, few numerical measures. So we boiled down 2200 observations down to just 4 numbers. It can be either counts or proportions. And proportions, by the way, the last thing that I want to point out, these proportions can be, you can think of them as probabilities, right? So if you randomly select one person from Titanic, completely randomly, 40% chance that this person was part of the crew, right? 14.8% chance that they were traveling as a passenger of the first class, 13% that they're second class passenger, and 32% that they're third class passenger. So these, you can think of these proportions as calculated probabilities that randomly selected person from Titanic was part of the crew, or first or second or third class. Okay. So that concludes our second lecture, ladies and gentlemen, and in the next part we're going to take a look at how we can plot graphs using R, and we're going to also discuss what are the different types of data out there. Okay.